I'm gonna call me Tutaa. Can you be my Tutaa? I'm about to feel like Tutaa. Can you be my Tutaa? I'm about to feel like...
Hello everyone, my name is Benjamin and I am your tutor. In today's video, we are going to be looking at set notation. So, what is set builder notation? Set builder notation is referred to as the symbols we use to describe everything about sets. For example, the same way we have symbols like plus or minus that describe and represent the addition or subtraction of numbers, is the same way we have symbols that describe the operations and the things we learn about in set theory. So, what are some of these symbols or notations we learn about in set theory? Well, we can start with capital letters. A capital letter such as the letter A, B, C, and so on will be used to represent a set. What we are saying here is that capital letters such as A, right, B, C, D, E, F, and so on can be used to represent a set. Let's take a look at myself. My name is Benjamin. Benjamin represents me name-wise. In the same way, these capital letters that we have here, A, B, C, D, E, F, represent a set name-wise. So when we assign the letter A to a particular set, what we've basically done here is given it a name. So we can easily say set A to mean the name of the set is A, right? We can easily say set B to mean the name of the set is B, and so on. So when we assign capital letters such as A, B, C, D, E, F, we're basically giving the set a name. Now let's take a look at braces. Some of us may know them as brackets, but we can also call them braces. So these braces may also be used to represent a set. So now you might be wondering, like, tutor, you earlier said that capital letters such as A, B, C, and D can be used to represent a set. Why is it that braces may also be used to represent a set? Now, let's go back to the previous example that we had about myself, right? My name is Benjamin. That means that Benjamin represents me name-wise, okay? I also have a body, right? My body represents me physically. In the same way, when we say the name of a set is set A, right? The braces act as the physical part of the set. The capital letter A that has been assigned to this particular set is the name of the set. And the braces basically represent the set in a physical sense. So this is what we see about the set, right? The braces are what we see about the set. The same way my body is what you see about me. And this is how braces can be used to represent a set in a physical way. Now that we have that out of the way, let's look at small letters, right? We had capital letters, we had braces, and now we have small letters. So small letters such as A, B, C, or D will be used to represent an element of a set. Remember what an element of a set is? An element of a set is basically just a member of a set. So remember that in our previous video we said that a set is a collection of objects, and these objects can be referred to as elements or members of a set. In the same way, these small letters that we have here may be used to represent the elements of a set, which means that small letter A, small letter B, small letter C, small letter D, and so on are basically the elements of the set. They are the objects of the set. And when we have a collection of these small letters, they make up a set, because a set is a collection of objects. Not only that, numbers may also be used to represent the elements of a set. What type of numbers? Numbers such as 1, 2, 3, 4, and 5 can be used to represent the elements of a set. So now we want to talk about listing down and describing these elements of a set. A set can either be represented by listing down the elements or describing its members between the braces. And each element in a set is separated from the other by a comma. What exactly does this statement mean? Let's take a look at a simple example. Let's take, for instance, we have a set called A, right? We have set A here, and then this set A has elements such as A, B, C, and D. So we have the name of the set on this one side, and we have the elements of the set on this other side. And remember that when we're looking at set builder notation, we're looking at symbols that properly describe a set. So when we have the name of a set on this side and we have the elements of the set on this other side, this set is not properly described. So we need to use symbols, we need to use all these things, put them together in order to properly describe and represent a set. Okay, because this is the language we use to talk about sets. So we need to do a few things here. Let's get the name of the set, which is the capital letter A, and then we'll say equals. So in order for us to properly represent this set according to set builder notation, we're going to have to list down the elements of this set between the braces, right? So we're going to have our open bracket here, and then now we are going to list down what this is what listing down is. Listing down is basically just saying A, B, C, and D. We've listed down and then we can close the brackets. But remember that each element in a set is separated from the other by a comma. So our work here is not done. So we're going to put a comma here between A and B. We're going to put a comma here between B and C. We're also going to put a comma between C and D. So what we've just done here is properly represent the set A. On this side, we have the name of the set, which is set A, and on this other side, we have the physical representation of the set, which both includes the braces and the elements which are in between the braces. So what we've practically just done here is listed down the elements of a set in order to represent the set itself. We can see that representing a set by simply just listing down its elements in between braces is very easy. However, this notation is limited in its application. This is because if one wants to write the set of all natural numbers using set notation, one may not be able to list all the natural numbers and put them in one set. So let's take, for instance, we have natural numbers. What are natural numbers? So natural numbers are 1, 2, 3, 4, 5, 6, and so on up to infinity. We can't necessarily list down all the elements of this set of natural numbers. Why? Because it will never end, right? And that would be a lot of work. Imagine you're taught in the exam to list down all the elements of the set of natural numbers. How long is it going to take you? It's going to take you forever, and you never finish listing down these elements. So this is one of the major limitations of representing a set by listing down the elements of the set. However, there's a solution to this problem that we have here. Remember that previously we said that a set can either be represented by listing down the elements or describing its members between the braces. Now, we've only talked about listing down the elements, but we haven't yet talked about describing its members or describing the elements of a set between the braces. And this aspect or this process of describing the members of a set between the braces is the solution to the problem that we've described here with the issue of us trying to list down all the elements of the set of natural numbers, which is practically impossible. How exactly can we deal with this limitation by using the process of describing the members of the set between the braces? Well, we can write the set by describing the property that characterizes the elements of the set. I'll repeat that again. We can write the set by describing the property that characterizes the elements of the set. So remember that a set of natural numbers is a set that includes numbers like 1, 2, 3, 4, 5, 6, all the way up to infinity. In this case, what we've just done here is list down the elements, but obviously we can't finish listing down because it's continuous. But we can deal with this limitation by simply describing the property that enables each and every one of these numbers to be a part of the set of natural numbers. So let's take a look at this. On the left hand side, we have the name of the set, which is basically set A, and on the right hand side of the set is what we can say is the physical representation of the set. What we see here is that we have the letter X here. This X represents all the elements that belong to the set of natural numbers, right? The letter X represents all the elements that belong to the set of natural numbers. So rather than listing them down by saying 1, 2, 3, 4, 5, and so on, this is tedious work. It's a process, right? So we can simplify this process by denoting all these elements in the set of natural numbers with the letter X, which means that the letter X represents all these numbers that belong to the set of natural numbers. And this is what goes on in the process of describing something. So we break down the language, simplify it, and use a few symbols to basically represent a larger picture. Okay, and this is what we're doing here. So X just stands for all the elements that are in the set of natural numbers. When describing the elements of a set, the first thing that we do obviously is, we have our open bracket there, and then remember that X is representing all the elements in the set of natural numbers. So we're going to write it down here, which is on this part, and then we're going to have our full colons there. All right, and then after that we're going to have X itself as well written again, and we are going to say is a natural number. What we've just described here is read like this: all elements X, which is just this part here, this first part here, which means that all elements that are represented by the letter X, which is 1, 2, 3, 4 till infinity. Now we have this part here, the second part here, and for the second part we say such that X is a natural number. Now let's put this together, or let's read this together, because we've done it in parts so it can sound a little bit weird, but let's put it together. So what we're saying here is that all elements X such that X is a natural number. So when we say that all elements X such that X is a natural number, what we simply mean is that all the elements in this particular set have been represented by the letter X in such a way that all these elements represented by the letter X are all natural numbers. And just like that, we have represented the set of natural numbers not by listing down the elements of the set, but by describing the property that the elements of this set have in between the braces. Very simple, isn't it? In addition to what we've just talked about, there are more advantages of representing a set by simply describing its elements in between the braces. What are some of these advantages? Well, the advantage of this notation is that it is more general and it can be used even in the case where we can list all the elements. Let's take a look at a simple example that will help us understand this advantage. If we have a set A, and this set is a set of natural numbers between 1 and 7. Okay, so we have a set A, and this set is a set of natural numbers between 1 and 7. When we look at this set, we can easily list it down. It's different from a situation where we say set A is equals to the set of natural numbers. We know that listing down that set is impossible because the list is practically endless. But in this case, we have limits, and these limits are 1 and 7. We can easily list down the set of natural numbers between 1 and 7. So let's do that. So we have set A here, and we're going to have our open bracket. So let's list down the numbers between 1 and 7. Okay, and these numbers are 2, 3, 4, 5, and 6. Just like that, we've listed down the set of natural numbers between 1 and 7. So we can see that listing down is very easy. Now let's remind ourselves of the advantage of representing a set by describing the elements of the set between the braces as compared to listing down the elements of the set between the braces. The advantage is that this notation is more general, and because it's more general, it can be used even in the case where we can list all the elements. In this example here, we've listed down all the elements of the set. Let's try and describe the elements of this particular set. So we're going to have set A here, and then we're going to say open bracket. So in order for us to describe the elements of this set, we have to represent the elements of this set that have already been listed down in a much simpler way. We have to reduce these elements that we have here to a single symbol. And what symbol did we use in the previous example? We used the symbol X. X is going to represent all the elements in this particular set. Wherever we see X, X stands for 2, 3, 4, 5, 6. All the elements 2, 3, 4, 5, 6 are represented by the letter X. So in our description, we're going to say X here. Then we're going to have a full colon there, and we can now begin the description process. So we're going to say X again is a natural number. Okay, Not only that, it doesn't end here. Remember that we've said that set A is a set of natural numbers between 1 and 7. So our description doesn't end here. So what are we going to say next? We're going to say and 1 is less than x, and x itself is also less than 7. And then we're going to close the bracket there. What we have done here is simply describe the set. And how do we read this whole thing? So we're going to say all elements x, which is this part, the first part, such that x is a natural number between 1 and 7. Okay, so this is how we read what we've basically described here using set builder notation. And this, ladies and gentlemen, is how we can basically describe the elements of a set, even though we're able to properly list them down. And that's one of the advantages of being able to describe a set in order to represent it. Before we can come to the end of the video, let's look at a few more notations. So what do we have here? If A, which just basically means set A, if set A consists of no elements, we call it an empty set, and it is denoted by A is equals to this symbol right here. Or equivalently, we can say A is equals to these two empty braces here. So we can use these two empty braces here, or we can use the symbol here to basically mean that set A is an empty set, or set A has no elements in it. So that's some of the notation that we can use in order to represent a set that is empty. What other notation can we look at? We have a situation here. If A is a set and X is an element, we shall write X, this symbol here that looks like an E, A, to mean X belongs to A. What this part here simply means is that the element X is a member of set A. And this symbol that we have here that looks like an E is what we use to denote that a particular element belongs to a particular set. What we're simply saying here is that X is a member of set A, or X belongs to set A. Now, in a similar situation, if we have the element X again, and now we have this same symbol that looks like an E, but now this time around, it has a line passing through it, and then we have A there, what we simply have here reads X does not belong to A. What we simply have here reads or means X does not belong to A. So it's basically just the opposite of what we have here. And what we're saying is that the element X is not a member of the set A. And that, ladies and gentlemen, is the end of this video on set builder notation. I hope you have loved the video. I hope you have enjoyed the video. Thank you very much, and see you in the next video.
Can you be mine?